And what is the structure? So here, as I already said, just to recall, user poses a query or the request to a local DNS server. From the local DNS server, the query will be redirected to root DNS server. From root DNS server, the query will be in turn sent to maybe TLD DNS server, or it may be in turn finally reaching our authoritative DNS server. So I hope you all remember that. If at all you don't remember, I'll just show you this. Recursive. Say for example, our user here is requesting for a particular website. So wherein first he wants the IP address of that particular server. So for that DNS query will be posted from requesting host to local DNS server. But local DNS server, if he is not maintaining the IP address in his cache, that query will be redirected to root DNS server. Again, root DNS server should give you back the what is that IP address of TLD DNS server. But what is that IP address of TLD DNS server? We have that maybe it is .com or .ed or .org or .in, depends on that, right? So root DNS server will in turn give you the IP address of TLD. Later your query will be redirected to TLD. Again, your TLD will give you back the IP address of authoritative DNS server, where you will get the actual IP address. Next, the query will be redirected to authoritative DNS server. Again, authoritative DNS server should give you the actual IP address of the web server that the user is requesting. So after 7th step, you can see now your local DNS server is getting the actual IP address. Now that IP address, whatever he has got, he will be redirecting to the requesting host, and in the final stage our host will maintain develop a TCP connection from itself to the remote web server, and that's how the communication begins from the requesting host to the remote server. So everywhere you can see here, query is posted and you get a response. Here also, query you post and you get a response. Query you post and get a response. So everywhere the query and answer you will be getting, and that also has a certain format. You call it as DNS query format or DNS response format. Okay, so just to see here, this is a query format, DNS query, and the DNS reply format. Both query and reply has the same structure. You can just see here, it is the one sorry, you have this header part. Header part is this first part actually, wherein you have this header part, 12 bytes header. Okay, so in this 12 bytes header, you can see the first field is 16-bit field. Sorry, for 15-bit field, 16-bit field, identification field. And what is this identification? It is a unique number assigned to each query, DNS query. And remember that same ID is also used for its response, its reply message. Suppose if you are querying root DNS server, that query will have an ID, and that same unique ID will be assigned for the reply that you are getting from the root DNS server back to the local DNS server. So query and reply both will have same identification. Next you have flags. You have here many flags. Each flag is of 1 bit there. Okay, so what is that flag indicating there? 1 bit flag indicating. So if that flag is set to 0, it indicates it is query field. If this flag is set to 1, it indicates that it is a reply field. So what is the meaning of that 1 bit query field? So you have many flags, out of which one flag is query flag. What is that query flag means? If it is set to 0, it means that this entire message what is sent is a query message. If the flag is set to 1, it indicates that entire message is a answer. It is a reply field. Why? Because the same structure is shared for both query and reply. Okay, similarly here one more flag you have, that you call it as recursion flag. What do you mean by recursion? We have already seen the recursion thing happening there. I hope you all remember this recursion happening here. Yeah, what is this recursion here? Query is posted to local. Local doesn't have any cache, so it will send to root DNS. Again, if root DNS doesn't have information about TLD, what root DNS should do? It has to query TLD DNS server and ask for its IP address. So in the 6th step, TLD will be sending back the IP address of itself to root DNS, and after 7th, again you see here, if TLD doesn't know about this authoritative DNS server IP address, again TLD has to post the query to authoritative DNS server. So authoritative DNS server will send back the IP address. After 5th stage, IP address is obtained at TLD. TLD can cache it. Again TLD will send the IP address of itself to root DNS server. So root DNS will cache it. Again root DNS server in the 7th stage will transfer the IP address back to our local DNS server. So this is also happening. So you all just see here, in 2nd step query is sent, 3rd step again query is sent, 4th step also query is sent. So finally our authoritative DNS server will start sending the reply, and the reply is in the form of what? IP address of what? Actual web server, and that IP address will be embedded, encapsulated. Along with that, TLD's IP address also is sent to root DNS server. Along with the TLD's IP address, your actual IP address of web server also is sent in 6th step. Okay, so root DNS server is getting TLD's IP address as well as actual IP address of web server. After 7th step, you can see IP address of which one is sent there? IP address of the actual web server is sent in the 7th stage. That is what local DNS server is expecting, right? So after 7th stage, the IP address of actual web server here is stored in the local DNS cache, and in the 8th step, the requesting host will be getting the actual web server's IP address. That is recursion happening, right? So this is happening, recursion is happening only when DNS server doesn't have the information about the other DNS server. When root DNS doesn't have the information about TLD, or TLD if it doesn't have the information about authoritative, this recursion is going to happen. Okay, so I hope you all know by now what is recursion there. Okay, so we'll just see the I'm sorry, we're going back. We'll just go to the next slide where we had stopped. That is about this flags, right? So recursion, if the recursion is required, you set the flag, otherwise no. So similarly, you have the next one, there is one more flag called authoritative flag, so which indicates that reply is authoritative. Authoritative means what? If the reply you're getting from the authoritative DNS server, that is authorized one, that is from the actual server, if you're getting the reply, so there also if the flag is set, it indicates that you're getting the reply from authoritative DNS server, right? So that flag is also there, right? So the next field you can see the question field. So question ID, you can see here the questions, and the next one is the answer resource record, and RR indicates answer resource record. This is the query thing sent, and this is the reply thing sent. Okay, and here you have a query record. This is the record, entire record. Query record, this is our answer record. Resource record format we have just seen in the previous slide, that same record format. Okay, next here you have authoritative resource record and additional resource record. What is this authoritative resource record means? Authoritative resource record indicates the resource record getting directly from the authoritative DNS server. So this is actually the one which we are looking for, right? Authoritative resource record which contains actual IP address. Additional resource record indicates, see, sometimes your authoritative DNS server may contain various list of IP addresses for the same website. For example, if I'm searching for Google web page IP address, there may be many Google servers which contains the home page of Google, right? So there basically I don't want all those web servers IP address, but then authoritative resource record contains list of all those web servers IP address. So those list, there's some additional resource records are nothing but those extra IP addresses of the which will redirect me to this different web servers, but all those different web servers will have duplicate contents. What is that? Same homepage of Google only is residing in several web servers, Google web servers. So such additional resource records also might be there. Okay, yeah. Next is this one. Yeah, questions. Actual question you have here, actual answer. This is the body section. Till here it is the header section, 12 bytes, and the rest onwards here comes the body part where the actual content of the question, actual answer of the question, authoritative. So all these actual contents are stored here. Okay, so I hope it is clear here. Yeah, actual question, when you say the resource record type, name field will be there, value field will be there, type field will be there. So that is in this question part. Similarly, response part also you have here. Response part will be something. What is that response part? You will have the corresponding IP address if it is type A record, or if it is canonical, if it is CNAME, it will be canonical name, and then DNS server name if it is type NS record. If it is mail server, it will be again canonical name of mail server. So that answer field will be entered here. It will be available here in this next section. Okay. Records for authoritative server and all that, right? Okay, so this is actually the structure of the DNS message, DNS query message or DNS reply message. And next one example we have. With that we can wind up our DNS concept. So this is the example which you have to follow up. This is the case study which you have to follow up actually. Yeah, this is a summary of this entire DNS concept. Just quickly we will have a look at it. Yes, so if suppose I'll not take this example, okay, I'll just take our own example. I want to register one domain. So register one domain in the sense I want my own domain to set up. So that domain I would name it as computernetworks.com. That would be my own domain that I'm going to set up now. I want to have something like, say, canaraengineering.in. Our institution has bought our own domain. So canaraengineering.in. So that is our own domain what we have, right? Similarly, all organization, infosys.in or infosys.com we have, or tcs.com we have. So all organizations have their own domain, right? So you call this as domain, their own website address, their own address. So from where do they get it? So how do they get it? So these are the steps to have your own domain. If you want, say for example, any one of you want to set up your own company, or you want to have your own firm. So what are you going to have? You're going to name your company first, and once you name your company, once you start your company, so next thing is you want to have your own website, for which you have to do you have to follow certain steps, right? So registering your company, you something like you own a website now. So for that you have to first buy this domain. So how do you register your domain? Okay, that is what is shown here, different steps. So first thing is I want to have my own domain. So I'm going to name my domain as, say, I'll take this one, networkutopia.com. So this is my firm that I'm going to start, and my domain name I have decided, and that decided domain name is Network Utopia. That is my name that I'm going to give. And .com, I'm going to register in com. I'm going to have my domain name as .com. Okay, so my new website is going to have a new name now, that is networkutopia.com. So now if at all I want to have my own domain, what do I have to do it? I want to register myself. I have to register myself. So you have something called as a standard organization registrar with whom you have to register yourself. See, the first step is, there is one commercial entity. It's something like when you want to buy anything, when you want to have when you want something, you just go to a shop, pay some amount and buy it, right? Same way here also, you want to buy something online, or space, your own space in the cloud, for which you have to pay some amount, right? So here I'm going to pay the amount to registrar, one who is our standard organization. So you just pay some amount and register yourself. Okay, so now once he will check for, the registrar will check for the uniqueness there. So uniqueness is what? He'll just see whether this name networkutopia.com is already used by someone or not. Okay, if it is already the name is already used by someone, then in that case we cannot have this particular domain name, right? I'm sorry, we cannot have this domain name. So uniqueness is seen, and after that, this is something like if you want your own account, they will Gmail will check for the uniqueness. If it is already used, then you have to change your username, right? So same way here also, uniqueness is seen, and once your domain name is unique, once they find it's unique, they are going to have they're going to register your name, or they're going to store your particular domain name in the database, in their database, and that database is a DNS database, and they'll collect some amount from you, right? So your name is now registered, your name is stored safely in their database, standard database, which is available globally, worldwide. Okay, done. So once you're registered, the second step is what? Second step is, now the registrar will ask you the list of IP addresses or the list of host names that you are going to have in your company. For example, I'm going to start my own company, and my company name is networkutopia.com. My website, I want to have a unique name for my website, that is again networkutopia.com. I've registered by paying an amount. After that, they are going to ask me for the list of IP addresses that my company will have, or my company, I'll hire maybe 10 employees initially. So for all those 10 employees, I'm going to give systems, right? So their own systems, laptops or tabs or anything. So I'm going to provide, and all those 10 systems have 10 different IP addresses, and those IP addresses should be registered in my site. Why? Because all the information that is entering to my office, it should be through me. It should be, that is entering my organization, right? So all those information that is entering my organization should be a secured one. Similarly, when we send the information out of my company, that also should be a secured one, right? So for that, all the IP addresses of my company, all the systems that my colleagues will be, my employees will be using, all their IP addresses, I'm going to store. I'm going to send them to the registrar. Registrar will ask me for that. Also their host names also they will ask, right? So all the host names and all the IP addresses of my company employees, all will be registered in the registrar's database, standard database. That's done. Yeah. Now what next? My company, for my company, I'm going to have one authoritative DNS server. Since it's my small company, I have only 10 employees, I'll have only one authoritative DNS server. What is that authoritative DNS server? Again, that is owned by me. That DNS server is owned by me. So that DNS server will have again all list of all IP addresses of my employees systems, and also it will have the host names of all my employees systems, right? So that complete information, that a complete table of information containing the list of IP addresses will be stored in my DNS server, authoritative DNS server belonging to my company. So if my company is a little bigger company wherein I have 200 employees, it's a quite big number. 200 such systems information I should maintain in a authoritative DNS server. In that case, one authoritative DNS server may not be enough. So in that case, I may have to go for 2 authoritative DNS servers. So here there is an example of 2 such authoritative DNS server. You have DNS1 and DNS2. So both are having same domain. See, networkutopia.com, networkutopia.com. DNS1 and DNS2 are the 2 host names of those 2 authoritative DNS server. Both are belonging to my own organization, right? And their IP addresses, see, it is mentioned here. 212.212.212.1. This last part is differing. The second one has again 212.212.212.2. See, all that means what? All my company, all my employees in my company have the same the first 4 parts of IP address are same for all my employees systems, whereas only this last 4th part is unique. That differs. That part we'll see in the next module. Okay. First you just see here 2 different IP addresses for 2 different authoritative DNS server. Remember, both of them are belonging to my own organization. After that, what do I do? For each of these 2 authoritative DNS server, now registrar will fix the type records. So what is that? Fix the type records. For example, I have 4 types of records: type A, type NS, type MX, and then one more is what? Type C name, right? So now basically, what is my address saying? Domain is .com, right? So my information should be stored in which TLD server? So TLD server can be many. It can be .com TLD server, or .edu TLD server, or .in TLD server. There are several, but since I have purchased .com TLD server, my information in the sense my authoritative DNS server's information should be stored in .com TLD server only. So whose job is that? It is registrar's job, standard organization registrar's job to collect the authoritative DNS server's names or authoritative DNS server's IP address of my organization, and that collected information should be stored in which one? In .com TLD server only. So .com TLD server is maintained globally, and that .com TLD server will have the information about my authoritative DNS server. It may be type A record or type NS record. What is type A record? So .com TLD server may have directly my IP addresses of authoritative DNS server, or if it is NS type NS record, then .com TLD server will have DNS server name or the authoritative DNS server name in TLD server. So what is that? DNS1.networkutopia.com and DNS2.network.utopia.com. Those are the two information that might be stored in my TLD com server, or some, if it is only type NS record. If it is type A record, directly IP addresses of two authoritative DNS server will be stored in TLD com servers. Remember, okay? So once this is done, what next? If as I already said, my company, if it is a big company, I'll have two servers, two DNS server. One I would call it as primary authoritative DNS server. The other one I would call it as secondary authoritative DNS server. Okay. So yeah, okay. So now what is that? COM TLD server, it is enough for COM TLD server to contact primary authoritative DNS server. What do you mean by primary? This primary authoritative DNS server is the one which is actually having a contact with outside world. This secondary authoritative DNS server is the contact for internal people inside the organization. DNS1 is primary. Suppose if this is primary, that means this is maintaining relationship with foreign. This is maintaining information with outside world, whereas DNS2 is maintaining contact with the inside world, inside the organization. So for our COM TLD server, it is enough to contact primary DNS authoritative DNS server. Since this is outside world.com, it's enough if it contacts our primary authoritative DNS server. So our COM TLD server may have the information something like this. See, networkutopia.com, this is the first part, that is the host name, whereas second part, it can be DNS server name. Which DNS server name? Primary DNS server name, that is DNS1.networkutopia.com, and what should be the type? Type NS only. And if it is type A record, it can be, the first part is what? DNS1.networkutopia.com. What is that? From the first part, it has just now obtained the answer. What is that? DNS server's name it has obtained. So using that DNS server's name, if it passes that DNS server name here in the second query, what would be the answer that you're getting? The IP address of that particular system. What is the IP address of this primary server? 212.212.212.1. And what is the type record? Type A. So two such resource records will be maintained in TLD com server. One is containing the DNS server name for utopia.com, that is primary DNS server name, and one more is for that primary DNS server, the IP address. This IP address also will be stored in TLD com server. So remember, this is the information only about primary authoritative DNS server, not the secondary authoritative DNS server. Okay, and this type A server, yeah, same thing actually applies for our type MX records also, like, because my company people also will be sending mails. For mails, these DNS servers may not be used. For mails, a different DNS server should be used, that is mailing DNS server. So in that case, the type of record would be MX, remember. Okay, so with this, now finally outside people can visit our company website, or they can also send email to our employees, or our employees can maintain relationship with the outside world. They can send email to other people outside the company. Okay, so these are the steps to set up your own DNS server, or once you start up your company, you can have your own website, your own domain there. to your company. Okay, right. So next, finally, one example for this entire DNS. Suppose our friend Alice wants to communicate or wants to visit, one outsider wants to visit your company website. My company website is what? networkutopia.com. So suppose one outsider, someone who is residing in US or Australia, wants to visit our web page. So what Alice would be doing, one who is residing in Australia, so she'll be opening her browser where she will type networkutopia.com. And now on her web page she should be getting, on her screen she should be getting the home page of my company, homepage of my company, that is networkutopia.com. So what are the steps to obtain the homepage of my company? We just see here. Yeah, okay. So first, Alice is a client here, so she'll be requesting now, right? So Alice is a host. First, as a client, she will send the query to her local DNS server. Local DNS server is the DNS server which is nearer to her, which is part of her organization, right? So Alice host will first send as a client, she will send the query to her local DNS server, and once her local DNS server, local DNS server will check its cache if already it has the IP address of my company. What is that? networkutopia.com, the web server of my company, its IP address of web server of my company, whether that IP address is existing in local DNS server of Alice or not, that will be checked here in this first step. So if local DNS server doesn't have in its cache about IP address of my company or my web server, then in that case what local DNS server should do? Redirect the request directly to root server first. So before the second step, root DNS server will be contacted. Through root DNS server, next TLD server will be contacted. Which TLD server will be contacted here? DNS server will contact TLD server. Which one? It is .com TLD server, what our local DNS server will contact. So you can just go back and see the diagram of DNS query and response thing, just now what we discussed. So TLD com server will be contacted, and the next stage, once through TLD, our TLD will be having two types of information. What is that? One is my primary authoritative DNS server name, that is type NS record, wherein it will have my DNS server primary, that is DNS1.network.utopia.com, that is type NS, and one more is type A record it has, right? So what is type A record? DNS1.network.utopia.com, and direct the IP address of my authoritative DNS server 212.212.212.1. That IP address also is available in .com server. Who has maintained that? Registrar has already maintained that, right? So once the TLD com server replies to whom? Local DNS server with the two types of records, what our local DNS server will do? Well, that local DNS server will directly get the IP address of what? IP address of authoritative DNS server belonging to my organization, and that IP address is 212.212.212.1, right? So this is type A record. Now our local DNS server, one who is belonging to Alice, will be getting the IP address of my authoritative DNS server, primary authoritative DNS server. So once is getting the contact, what our the local DNS server can do? Directly local DNS server can send the request to my primary authoritative DNS server with the help of this IP address, and through my primary authoritative DNS server, what Alice will be getting now? My primary authoritative DNS server will contain all the IP addresses of my company, all the IP addresses of the web servers of my company will be existing in primary authoritative DNS server, with the help of which the IP address will be redirected to the local DNS server, and local DNS server will finally redirect that IP address to Alice host. Now Alice will be getting the IP address of my web server. Now Alice browser will directly initiate a TCP connection to my web browser, through which my web server will extract the home page of my networkutopia.com and directly post to Alice screen, and Alice will be able to get the beautiful view of my company website. So this is all happening through HTTP connection. HTTP is application layer protocol. TCP connection is happening in the transport layer, below layer, okay, whereas in the topmost layer HTTP will be running. So HTTP is the protocol through which web server, the client server interaction is happening, but this basic translation from host name to IP address is happening through which application layer protocol? It is happening through DNS application layer protocol. I hope with this example you must have understood all the concepts of DNS, right? I hope it is clear. Okay.